Section 3.4, Equivalent Statements. Two statements are equivalent, which is symbolized by either of the symbols shown here, the double-sided arrow or the equal sign with an additional bar above it, if both statements have exactly the same truth values in the answer columns of the truth tables. If the answer columns are not identical, then the statements are not equivalent. Sometimes the words logically equivalent are used in place of the word equivalent. Use a truth table to determine whether the two statements are equivalent. So one way we're going to learn to determine equivalency is by using truth tables. So we're going to create the truth table for each compound statement. So for the first compound statement, if not P, then not Q, there's my truth table. And then the second compound statement is if P, then Q. And we notice here we have different values in the answer column. So therefore, these statements are not equivalent. We notice on the left side we have true, true, false, true. And on the right side, we have true, false, true, true. Determine whether the following two statements are equivalent. So again, we're going to use truth tables this time, and we've already created these. There's 3 simple statements, so 8 cases. And we notice for the first compound statement, P and then in parentheses, Q or R. And here's our column here with our answers. And then on the second statement, P and Q, or, and then in parentheses, P and R. And we notice here, when we look down the column, we have the identical truth values in the last column of each truth table. So therefore, those statements are equivalent, and therefore we can write the statement on the left is logically equivalent to the statement on the right. Which statements are logically equivalent? Determine which statement is logically equivalent to, it is not true that the tire is both out of balance and flat. So we're going to let P be the tire is out of balance, and Q be the tire is flat. And we want to write the original statement symbolically, and it's going to be written this way. It is not true that, and then in parentheses, the tire is both, so that means an and, out of balance and flat. And then the second statement is an if-then statement. If the tire is not flat, so that's going to be an if not Q, then not P. The second statement, the tire is not out of balance, not P, or not Q. The tire is not flat and the tire is not out of balance. And then finally, if the tire is not out of balance, which is an if not P, then not Q. Now, we've got 4 statements here, and we want to know which of these is logically equivalent to the one we started with, and we're going to do it with truth tables. So we took the first statement, it is not true that, and then in parentheses, P and Q. And here's our answer column here, false, true, true, true. We took each of the 4 statements symbolically and created the truth tables, and we notice that the only one that's logically equivalent is the second one. So the negation of P and Q is logically equivalent to the negation of P or the negation of Q. So we can write this equivalently to say the tire is not out of balance or the tire is not flat, and that's logically equivalent to the original statement. And that leads us into DeMorgan's law. So if we go back for a second, you'll notice that this is one of DeMorgan's laws, the first one here. The negation of the conjunction is logically equivalent to the disjunction of the negated simple statements. The second DeMorgan's law says the negation of the disjunction is logically equivalent to the conjunction of the negated statements. Write a statement that's logically equivalent to, it is not true that tomatoes are poisonous or eating peppers cures the common cold. So we're going to pick our simple statements, and we want to write this statement symbolically now. It is not true that, so we're going to have a negation and then parentheses. Tomatoes are poisonous, which is P, or eating peppers cures the common cold. Now we can use a DeMorgan's law, the second one, to rewrite this. It's equivalent to the negation, the conjunction of the negated simple statement. So therefore, a logically equivalent statement is tomatoes are not poisonous and eating peppers does not cure the common cold. Write an equivalent statement for this. It is not true that you are $1 late and a dime short. So P is going to be you are a day late, Q is you are $1 short. Write it symbolically. It is not true that P and Q rather. And again, we can use a DeMorgan's law. And how's that in words? It's going to be you are not a day late or you are not $1 short, which is answer C. Use truth tables or DeMorgan's laws to determine whether the two statements are equivalent. So we can rewrite the one on the left side using DeMorgan's laws, because we know a DeMorgan's law for that one, and we can rewrite that in this format here. And we notice this is not what we were given as a second statement, so therefore the two statements we were given originally are not logically equivalent. Here are some other ones that are nice to know. We can take a conditional and have a logically equivalent statement as a disjunction. So if P then Q is equivalent to not P or Q. So that's one nice equivalency to know about. So write a conditional statement that's logically equivalent, a conditional now. The cows are in the pasture or the horses are not in the barn. So we pick our simple statements. We can write that original statement like this. Now we just had a way to write a conditional as a disjunction. We can go the other way, negate the first one, change the disjunction to a conditional, keep the second. So we can rewrite this as, if the cows are not in the pasture, then the horses are not in the barn. So the negation of a conditional written as a conjunction, here it is here, the negation of if P then Q is logically equivalent to P and not Q. Write a statement that's equivalent to, it is false that if you hang the picture, then it will be crooked. So pick our simple statements, write the original sentence symbolically. It is false that if you hang the picture, then it will be crooked. And that we know that's logically equivalent now to P and not Q, so we can rewrite that as you hang the picture and the picture will not be crooked. There are some variations of the conditional statement that are also useful when you're working with finding equivalent statements. We have a converse, an inverse, and a contrapositive for the conditional. So if the original conditional is if P then Q, the converse flips the order of the simple statements, if Q then P. The inverse keeps them in the same order, but negates both simple statements. If not P, then not Q. The converse does both. It flips and negates. If not P, then not Q. The conditional and the contrapositive, the conditional and contrapositive are logically equivalent. The converse and the inverse are logically equivalent. And you can show that by creating truth tables. For the conditional statement, if the painting is by Andy Warhol, then the painting is valuable. We want to write the converse, the inverse, and the contrapositive. So we'll let P be the painting is by Andy Warhol, Q, the painting is valuable. So the original statement is written like this, if P then Q. Now we want to write the converse, and that's going to be if Q then P. So if the painting is valuable, then the painting is by Andy Warhol. The inverse keeps the simple statements in the same order but negates them. So if the painting is not by Andy Warhol, then the painting is not valuable. And then finally, the contrapositive, we flip this order of the simple statements and negate both of them. If the painting is not valuable, then the painting is not by Andy Warhol.